All right, today we're going to do exponential functions practice 2. Use the graph to find the characteristics of the function. So looking at this function here, I can identify that my a term is equal to 2. My b term is equal to 3, and my b, remember, is my ratio. Because I do not have a constant being added, I know that it's really going to just be 0, okay? So these are all the important parts to my exponential function that I can use to identify key features. Because my b term is greater than 1, I have exponential growth. My asymptote is going to be y is equal to 0 because there is no number here, so that will be my asymptote. My domain is going to be all real numbers. My range will be y is greater than 0 because it's never going to touch that x-axis. And then my y-intercept is going to be 0, 2 because of my a term. If you want to check that, make sure that you have the correct y-intercept, you can also plug in 0 for x. So you would have 2 multiplied by 3 to the 0 power, which is just equal to 2 times 1, because anything to the 0 power is 1, and that's going to equal 2. Which makes sense because if you look over here at the graph, that is my y-intercept. All right, moving on to number 2. Use the graph to find the characteristics of the function. Okay, so we have our a term here. My a is equal to 3. My b is equal to 1/2. Because my b term, my ratio, is less than 1, I know I have exponential decay. Then I have this plus 4. That plus 4 is going to be my asymptote. So y is equal to 4. And I can add that to my graph right there. My domain, all my possible x values, well, that's going to be all real numbers. My range, again, is going to relate back to my asymptote. So it's going to be y is greater than 4. My y-intercept now, because I have this 3 and the 4, my y-intercept is going to be 7. And if you look over here at the graph, you can see right here that your y-intercept is at 7. To double check it, you can plug in 0 for x. So you're going to have 3 multiplied by 1/2 to the 0 power plus 4. 1/2 to the 0 power is 1. So 3 times 1 plus 4 is equal to 7. All right, number 3, use the xy table to graph the function, then find the characteristics below. There's two things going on with this function. We have that -1, which is being applied to the x, our exponent, and we have this -3. That's going to affect our y-intercept. So we can't just use our a is equal to 1 as our y-intercept because of those transformations. So even though our a is equal to 1, it's not going to be that helpful right now. My ratio here is 4. And because my ratio is 4, I know that I have exponential growth. My asymptote is going to relate to that -3. So I'm going to have y is equal to -3. And I can put that on my graph right here. My range is all my possible x values. So that will be all real numbers. My domain, sorry. And my range relates back to my asymptote, so that's y is greater than -3. Now to find our y-intercept, we're going to plug in 0 for x. so we're going to find f of 0. That's going to equal 4 to the 0 minus 1 power minus 3. Well, 4 to the negative 1 power is going to be 1/4. Anytime I have this negative exponent, it's going to become a fraction. Then I need to subtract 3. Well, 1/4 minus 3 is going to be negative 2 3/4, or negative 2.75. So I'm going to put that point here on my graph. And there we go. I'm not going to worry about -1 and -2 because I know the general direction of my exponential function, and I know it's going to approach -3. I just don't want to deal with those decimals. But we do need to find f of 1. And to do that, we're going to do 4 to the 1 minus 1 power minus 3. Well, 1 minus 1 is 0, and 4 to the 0 power is 1. So 1 minus 3 is going to equal -2. So at 1, I'm at -2. Then I'm going to find f of 2, and that's going to equal 4 to the 2 minus 1 power minus 3. Well, 2 minus 1 is 1. 4 to the power of 1 is just 4, minus 3 is 1. Positive 1. So at 2, I'm at positive 1 all the way up here. There we go. And then f of 3 would be 4 to the 3 minus 1 minus 3. Well, 3 minus 1 is 2. 4 squared is 16. 16 minus 3 is 13. So there's my exponential function for number 3, and that is showing exponential growth. All right, our last one, number 4, we're going to use the XY table to graph the function, then find the characteristics below. So here we have our A term, then we have our ratio of 1/2, and we have this positive 3, which is causing a transformation on that function. So remember, if my A is equal to 2, to find my y-intercept, I'm going to have to add that 3 because of that transformation, and that's going to equal 5. Because my B term is equal to 1/2, which is my ratio, I know that I'm going to have exponential decay. My asymptote is at 3, so y is equal to 3. 1, 2, 3, and there's my imaginary line that function is never going to cross. My domain, all my possible x values, is all real numbers. My range, of course, is going to relate back to my asymptote, so y is greater than 3. Now I need to find the rest of the terms to fill in my table. So to find f of -2, well, then I'm going to have 2 to the 1/2 power to the -2, 2 multiplied by 1/2 to the -2 power, sorry, plus 3. 1/2 to the -2 power, you can type that into the calculator, and you're going to get 4, because it's the same thing as flipping that fraction, which becomes 2, and then squaring it, which is 4. So 2 times 4 plus 3 is going to be 11. Then you're going to find f of -1, and that's going to be 2 to the 1/2 power to the times 1/2 to the -1 power plus 3. 1/2 to the negative 1 power is going to become 2. 2 times 2 is 4, plus 3 is 7. We already know f of 0, and then we can find f of 1. That's going to be equal to 2 multiplied by 1/2 to the power of 1 plus 3. Well, 1/2 to the power of 1 is just 1/2. 2 times 1/2 is going to be 1 plus 3 is equal to 4. I found f of 2. That's going to be 2 to the 1/2 power squared plus 3. Well, 1/2 squared is 4. 1/2 squared is 1/4, I mean. And 2 times 1/4 is going to be 1/2 plus 3, and you're going to have 3.5. So we can go ahead and plot these points. We're going to just get another decimal here for number 3, so you can do the math there. I'm out of space. At 0, when my x is 0, my y is 5, so I'm going to plot that first. That's my y-intercept. When my x is 1, my y is 4. When my x is negative 1, my y is 7. And there is my function. All right, guys, that's it for practice page 4. Have a good day.